Okay, this is 5th grade, Module 3, Topic B, which is all about multiplying a fraction by a fraction. So the first method that we teach students is the area model. And let's say we have a problem that is 2/3 times 3/5. So here students would create a square. And we know that the multiplication symbol also means that word of. So I'm taking 2/3 of 3/5. And since I'm taking it from the 3/5, I'm going to actually draw the 3/5 first. So whatever that back fraction is, that's where I'm starting. So what I do is I cut this into 5ths, like so. And then I'm going to bundle 3 of them. So I'm going to count 1, 2, 3, group them just like this. Here is my 3/5. Okay. Then what we do is we look at our 2/3. So I made columns for 5ths. I'm going to go ahead and make rows for 3rds. So I'm going to cut this into 3rds going the opposite direction. And I tell students sometimes that I realize they might get confused with all these boxes. So I'll tell them, if you're having trouble seeing the 3rds, make these lines just a little bit darker so you can clearly see where 3rds lies. And the numerator here is 2. So I'm going to go ahead and bundle up 2/3. So when we use an area model to multiply fractions, what we're looking at is what boxes fall inside of both the 2/3 and the 3/5. We compare it to using a multiplication table. So obviously I'm going to shade this one and this one because they both land in 2/3 and in the 3/5. And I'm going to also shade this one and this one for the same reason. And this one and this one. I wouldn't shade anything outside of that because it does not fall within both of those fractions. So on the test, they are going to see a model like this, and they're going to have to find the matching multiplication expression. So what we know is that this model is partitioned into a total of 15 parts, okay? This is another question that, something you're going to see in the future on the test. Of the parts, 6 of them are shaded. So 6 of the parts are shaded. So the model shows the product of what? Well, we look at the product being 6 shaded pieces out of 15 in all. So the product is 6/15. And that's how to solve using the area model. Oops. I do that every time. All right, so let's keep going. Move on to the next section. I'm sure there's a better way for me to do this. All right. So the next thing that we learned was the number line. And if you remember in Module 1, we had started discussing the number line. And it's basically the same thing. So if I have, let's stick with the same fractions. 2/3 times 3/5. So instead of having that whole number, such as 4 or 5, this time I actually have a fraction. So when drawing that number line, one side is going to be 0. And again, this means of. So this is the fraction that I'm working with first. So I'm going to go ahead and make 5/5 because that would be equal to a whole. And I'm looking at this denominator. That's why I'm using fifths. So 1/5, 2/5, 3/5, 4/5. I realize they're not quite perfectly even, but that's all right. Then our other fraction here is thirds. Well, first of all, let's look at this. This says 3/5, right? So I'm going to circle 3/5 because I know that's super important. That's kind of end up being my stopping point. And so 2/3. I'm going to go ahead and cut each of these units into thirds. And I'm going to shade in 2 of each unit. So 1, 2, 1, 2, 1, 2. And I'm going to stop at the 3/5. I'm not going to color or shade in anything on this side. So I can see that I have 2, 4, 6 pieces shaded in out of a total of 15 pieces. So that's just one more strategy to use. All right, this is the kids' favorite. So multiplying a fraction by a fraction and just multiplying straight across. They love this. You think, why didn't you teach us this a whole lot sooner? Same fraction, 2/3 times 3/5. We multiply going straight across. So 2 times 3 is 6. 3 times 5 is 15. And there's my answer. Now, we do want, at some point, the students to consider simplifying the fraction. It's not required at the moment, but we do want them to start thinking that way. So what I do is I tell them, okay, what could we divide both 6 and 15 by? What common factors do they have? Well, they both have a factor of 3. So I'm going to divide by 3 on the top. And whatever I do to the top, I must do to the bottom. So 6 divided by 3 is 2. 15 divided by 3 is 5. I can say that 6/15 is equivalent to 2/5. Now, each of these is completely acceptable on the test. There's no, oh goodness, I did it again. There's no right or wrong there. Okay, so here we're going to compare fractions. And this is really, really easy. It's just a matter of looking and really thinking about it. So let's say we have something times a whole number of 16 is less than 16. Well, in order to make this statement true, I would actually have to write a fraction that's less than 1 whole. So it could either be 3/4, it could be 2/3, 1/2. Doesn't matter as long as it's less than a whole. Now let's say we have same situation, but this time we say that it's greater than 16. We want to enter a fraction into that blank to make this true. Well, in order for this to be greater than 16, my fraction would have to be greater than 1 whole. So I could put 5/4, 3/2, anything like that that's greater than half. And then the last scenario would be entering a fraction that would make this sentence true. And so we know that anything times 1 is itself. So whatever fraction that we would put in this blank, it would have to equal to 1 whole. And they're going to see this on the test. So just keep all this in mind. Okay, the next section is to compare fractions yet again. But now we're kind of leaning into explaining why it works. So I want you to kind kind of consider the fraction, let's see, this one, sorry. Consider the expression. So what if I have 5/3 and I'm multiplying it by 5/2? Okay. So is blank 5/2? Well, you're going to have to determine, is it going to be greater than 5/2 or is it going to be less than 5/2, and why? So I know that the answer to this expression is going to be greater than 5/2 because 5/3 is greater than 1. Now I can guarantee you are going to see this on the test. So this is a very important skill to practice. Another example might be 2/3 times, let's say, 6/2. And then it says, is blank 2/3. Well, 2/3 is less than a whole, and 6/2 is more than a whole. So in this situation, 2/3 times 6/2 is going to be greater than 2/3. Because six halves is greater than 1. Just some things to think about. All right, and then on to the last slide. Okay. So it says we're going to read, draw, write. This is a word problem here. There are 45 cakes for sale at the school bake sale. 6/9 of the cakes are chocolate. How many chocolate with, 1/3 of the chocolate cakes have sprinkles. How many cakes are chocolate with sprinkles? Show your work. So look inside the box right here. I'm telling you that you need to read the entire problem all the way through. Then you're going to read the problem again, one part at a time, and then stop after every sentence. When you're doing that, you're basically working on the problem as you go. So by the time you get to the end and you get to that question, you know exactly how to solve it. By the way, for those of you who are needing that code, the secret code is HAPPY. So there are 35 cakes for sale at the school bake sale. So I'm going to go ahead and stop right here. 45 cakes. Let's draw a tape diagram. Total is 45. Okay. 6/9 of the cakes are chocolate. All right. Well, let's stop right there. So I'm going to have to cut this into ninths. I'm going to group 6 of them. 6. Here we go. All right. Next question says, how many chocolate cakes are at the school bake sale? Right there. So I know I'm going to have to divide 45 into 9 groups, which equals to 5. So each of these units or each of these boxes has a value of 5. So if 1 unit is equal to 5, then 6 units would be equal to 6 times 5, which is 30. So there are 30 chocolate cakes at the bake sale. All right, let's keep going. So it says 1/3 of the chocolate cakes have sprinkles. Well, there's only 30 chocolate cakes. So I'm going to make a second tape diagram. Go ahead and put 30 at the top. And my fraction here is 1/3. So let's cut it into 3 pieces. Group one of them, 1/3. Those are the ones with sprinkles. Okay? Question is, how many cakes are chocolate with sprinkles? So 30 divided into 3 units would have a value of 10. That means 1/3 of the chocolate cakes have sprinkles, which means 10. So 10 cakes are chocolate with sprinkles. All right, I hope this helps. For those of you who are looking for that code, I said it a few minutes ago. I really hope this helps and that you're enjoying the videos.